All right, this is in response to Connor's question about, I think it was 14 and 15. And I totally did not even begin to teach you this. So it makes perfect sense that you couldn't do it and why I was confused about the problem because we've never done anything like this. So it's not too hard though, so I'm going to go ahead and show it to you. So this was called consumer surplus and producer surplus. So the concept is, I thought this was an equilibrium problem. So an equilibrium problem is, let's say we have some function that represents our production. So let's say we have a function that represents our production, and a supply and demand is really what I'm looking at. So we have a supply and we have a demand. And equilibrium is where supply equals demand, where we are completely, everything we produce is being sold. We have no extras, nobody's in want. It's the complete equilibrium point of my supply and demand. When I first looked at it, I thought that's what we were doing, and I think that's why I picked the problem. So my apologies, I totally messed up by not explaining this. So this is the equilibrium point. So what they call the consumer surplus and the producer surplus has to do with when you find that equilibrium, I'm going to make it in green, and you create whatever the Y value is, you create the line that goes right, the horizontal line that's supposed to go right through that intersection point. Everything that is above your equilibrium point is called consumer surplus. And everything that is below, the area that is below there, is what is called the producer surplus. So as you can see, the areas that these two create are triangles, because a supply and demand is always going to be a straight line in our instances. So we're going to create some sort of a triangle, you notice, and therefore the consumer surplus will be this triangle here and the area of that triangle. And then the producer surplus will be the area of this triangle right here. So let's do an example where we have this kind of a problem. I'm going to look at my number 14. Yours will probably be similar, but not exact. So the profit is 160 minus 0.05x for my demand. This is my example for 14. And my supply function is P is equal to 70 plus 0.4x. So first we have to graph these 2 points. I won't graph them again. I'm going to try to figure out how to do some sort of tutorial on WebAssign graphing later. But I do want to know roughly what these two look like and like their intersections and stuff like that. So this guy right here is 160 minus 0.05x. So I want to figure out where, let me figure out where it crosses the y-axis. So that will be, I'm going to plug in 0 here. So 0 equals 160 minus 0.05x. And solving for that, 160 divided by 0.05, that's going to be 3,200. X will be 3,200. So that's going to cross at 3,200, be down here. We're going to say this is our 3,200 down here. And then if we're looking for the y-intercept, I'm not sure, I think I might have said that wrong last time. If we're looking for the y-intercept, we're going to plug in 0 for x. So that means that P will be 160. So we're going to say this is 160. So that's going to be the demand line. All right. And then if we're going to do the supply, this one is the supply. we'll say if x is 0, p will be 70. So we're going to say 70 is right. We're just going to put it right here. That's going to be my... And then if we solve for, we set it equal to 0. We want to find the x-intercept. Oops, that's not supposed to be a 0.04. It's supposed to be a 0.4. So that means that 70 divided by negative 0.4 will give us negative 175. X is negative 175. All right, so that x will be somewhere way over here. Clearly, that's not going to help us a whole lot. So, I mean, we know it's going to go through that way, but we're only looking for the positive side. So now let's see where they intersect. Let's find out what that looks like. 160, where that equilibrium is. 0.00. Oh my goodness. 10. 0.05x is equal to 70 plus 0.4x. Okay, so we're going to get 90 is equal to 0.45x, and then x will be 200. So that will be the x value. But remember, we wanted a y equals the horizontal line. So if we plug in 200 into one of our problems, it doesn't matter which one we plug it in because they should be the same. I'm going to say p equals 70 plus 0.4 times 200. So then we come up with 150. So p equals 150 is that horizontal line right here. Clearly mine is not, mine is poorly graphed, but you knew that. So p equals 150. All right, so again, we're looking for, if we want the consumer surplus, it's going to be the area up here. So this, it's important to note what point this is right here. This is, the x value is 200. And hopefully you see why that's important to note that point. I'm going to take off that right there. Okay, so the area of this triangle, the consumer surplus, would be area equals 1/2 base times height. So that will be 1/2. My base is going to be however wide this is. So if this was 160 and that's 150, it'll be 10. And the height will be this guy right here from 0 to that point of intersection, which is why this number here was important. So that will be 200. So we have 2,000 times 1/2, which will give us 1,000. And that will be my consumer surplus. All right, then we also have to find the producer surplus. Remember, the producer surplus is just this triangle down here. All right, so that triangle down there, again, it's just the area. So area will be 1/2 base times height again. Area equals 1/2. So we need our base. Our base is going to be from this point to this point right here. So this one was 150 and the bottom one was 70. So that should be 80. And then the height was exactly the same. It was still 200. So we've got 1/2 times 80 is 40. 40 times 200 is 8,000. That will be my producer surplus.